Yeah, hi everyone. My name is Igor. I'm the creator of Blue Wallet. Blue Wallet is an open source Bitcoin wallet that I started in 2017. And as far as I know, it's one of the first cryptocurrency wallets built with React Native, because the amount of bugs I encountered was like massive, but since then they were fixed. So right now we have pretty decent React Native cryptocurrency wallets, such as Coinbase Wallet or Rainbow Wallet, which is pretty popular. Yeah, so today we're going to be talking about how do we build a cryptocurrency wallet with React Native. So we're quite famous in our Bitcoin only niche. So for example, like a couple of years ago, we recorded a demo about one of our features I was working on, and Elon Musk dropped to our Twitter thread and asked, do you need a license for that? Yeah, and I don't know if you're following the industry, but a couple of years ago, there was like 2 weeks time when everyone were joking and making memes about, "Oi, mate, do you need a license for that?" Well, that was us who triggered it. Yeah, so we kind of know what we're talking about. Yeah, so first, what is a wallet? Wallet is a piece of software that acquires good quality entropy, keeps it safe, real safe, and does some operations with this entropy. This is usually a digital signature. Everything else is just bells and whistles. So entropy is the cornerstone of the cryptocurrency wallet. This is the most important topic of a cryptocurrency wallet. And well, it's not exactly correct to say that entropy is randomness or private key or mnemonic seed phrase, but for our purposes, it's okay to say that it's the same. So in conversation with your fellow developers, you can interchange. Sometimes you say entropy, sometimes you say private key. It's roughly the same. But what is entropy? Entropy is usually a very big number. It's actually 256 bits. It's a big number. It's 1 and 77 zeros. So this number is so big that it's bigger than number of atoms in an observable universe. That's what makes the private keys unguessable. That's what makes it secure. This is an example of a private key. This is just a really big number written in hex. So where do we get this private key? And we need this, like for example, when user just installed the wallet and he needs to create a wallet, we need to generate an entropy for the guy. So historically, we had a bunch of random functions in our programming languages, such as math random, but historically CPUs did not have access to entropy, to randomness. So usually when you access general purpose random function, you usually access some kind of counter that counts something all the time, then it overflows, and then it starts again. And this makes it extremely predictable. So the first big no is don't use general purpose random function from your environment, because it's extremely guessable. And even worse, you cannot know if it's 32 bits or what's the size of it. So I assure you, if you'll try to do that, just someone who reads your source code, he'll be able to, with some reasonable assumptions, he'll be able to guess all the private keys that you create from your randomness. Yeah, because think of it, there is a CPU. CPU is a very deterministic machine. It has machine instructions, it has memory registers, it has the conveyor of machine instructions which it executes. Where does the randomness comes from, right? There is no way to get the randomness. That's why we access some kind of counters when we access math random. And this is why it's called pseudo-random number generator. It's not a real random. To make things worse, it's impossible to tell if the entropy you acquired is good quality or not. There is no test to tell you if it's good or not. There are some very basic tests that might spot certain patterns in your entropy, but that's it. If it's flawed from the beginning, you're screwed, and your users are screwed. And the biggest fear probably of all cryptographers around the world is getting the flawed or even backdoored entropy, because there is no way to tell if your entropy is backdoored. You might use it, and then you use it, and someone eventually will be able to steal all your secrets. That's why all the companies around the world that are cryptography focused, they go a really big distance to acquire good quality entropy. This includes special chips that provide true randomness, that several of them. It includes mixing entropy from different sources, sometimes asking users. I'm sure some of them, like seen software where you have to randomly move the mouse or tap randomly on the keyboard to get the entropy. This is exactly this, to mix several sources of entropy to get more secure randomness. Yeah, so what we do as applications developer, we access operational system source of entropy, because operational system, actually, there are very smart people that work on operational systems, and they write pretty good cryptography-oriented code to have a buffer of entropy for all the developers like us to access. So what we do, we access this buffer. And if you're curious, how do you get this good quality entropy? There's usually some kind of sensor involved with big resolution. And if it has good enough resolution, the smallest bit of the sensor will always flip, like 10010110 all the time. So if you access it not too frequent, you'll be able to get this one bit of and add it to the pool. So maybe once a second. So think of it, you get 1 bit of entropy per second. So that's why it's quite slow, right? So you cannot just generate 1 terabyte of entropy. So that's why operational systems, they all have some kind of buffer of entropy which they gather, so developers like us could access it and get the good quality entropy. So what we do, well, as React Native developers, we've got several packages that provide access to native calls to get the from operational system. What we do, we might code it from scratch and write it in Java, in Kotlin, in Objective-C, or we use the existing package. But as if we're security focused, we must always verify. We don't trust. We open the source code of the package we're using. We're tracing down the exact code to the exact source of entropy, and we're opening the documentation for this call. And we must see with our own eyes that this is indeed a secure pseudorandom number generator. So it's not just PRNG, it's CSPRNG, cryptographically secure pseudo number random generator. So this is an example for iOS. It's very simple. Basically, the whole package consists of this, like, how much? 10 lines of code of Objective-C, just to get the safe entropy from operational system. And the Android counterpart is the same. And don't forget, you open the documentation for the secure random, and you must make sure with your own eyes that it says it's cryptographically secure, it's good to use for cryptography purposes. Yeah, and in case of you, we need entropy all the time. Every time we establish a secure connection to websites, there is entropy involved, and we need always source of good entropy on your iPhone, on your laptops, everywhere. Once we get the entropy, the good quality entropy, we usually need 256 bits. We need to store it, right? So on iOS and Android, all the latest devices have some kind of secure enclave to store your secrets. And this is the best storage currently we can get on mobile. So we need to find a package or write from scratch one to access those storages. We cannot rely on general purpose storage unless there is some kind of key store or keychain involved. Sometimes we can do something a bit different. We store something in a database that's encrypted and don't settle for less than AES-256 encryption, which is the golden standard of our industry of encryption. So if we make sure the database we're using a personal-like realm, but I think WatermelonDB has some kind of encryption. I'm not sure, maybe, what's the other one? SQL that you have with file. What's the name? The SQL? SQLite, right. I think SQLite has some kind of encryption. So again, if it has encryption, we have to provide the encryption key ourselves, which we get from cryptographically secure pseudorandom number generator, and then we store it in key store keychain. This is the other option. So anyway, there should be some kind of a key store or keychain involved in Android or iOS, and we use it. That's what we do. Otherwise, just other apps will be able to read our secrets. Next, so once we got entropy secured and stored, we're going to have to use some kind of JavaScript library for the coin we're going to write software for, and pretty good chance that we're going to use some kind of bitcoinjs fork or bitcoinjs, because a lot of standards are implemented under bitcoinjs umbrella. For example, BIP39, like 99% chance, whatever software you're going to write for whatever currency, there's going to be BIP39 involved under bitcoinjs umbrella. And this is specifically to convert entropy to mnemonic seed words. Yeah, and there are some gotchas. Like, for example, there's no crypto module in React Native. And some of the libraries you're going to use, there might not be designed for React Native. They might be designed for node.js, and they're not going to just work on React Native. So welcome to the bleeding edge, what we call. So you're going to have to hack node modules. You're going to maintain patches, or you're going to use something like Babel plugin that helps to the dependencies you use to resolve correctly the crypto, because React Native is quite a restricted environment. There's no crypto. Like if you try to require crypto in React Native, there's no crypto. It won't just work. So you'll have to solve it. And usually it solves with installing some native modules which provide crypto for React Native. And moving on, now we have Entropy. We have some JavaScript libraries we're using with our private keys. And then we're going to make network requests, because basically the private key is the thing that controls assets that we've got on blockchains, on different blockchains. So this is how it goes. You usually take Entropy, you convert it to private key. From private key, you make it an address, and then you can look up this address on some public APIs. 99% is going to be public API, sometimes paid. And you request the network, like what kind of assets are owned by this address. But be careful, because network requests leak privacy. So if you're really privacy-oriented, there are better solutions than just hidden public APIs. And OK, so let's say we've done that. And at this point, we've got 75% of wallet done. Yeah, next thing to finish is just implement sending functionality, and that's it. 100% of your wallet is done. So let's talk a bit more on the topics that are really important when working with cryptocurrencies. So dependencies are a liability. This is also known as a supply chain attack. So as a JavaScript or TypeScript developers well know that node modules is like a huge black hole with who knows what in there, right? So, and they also execute post-install scripts, and they're really not safe. There have been cases like a couple of years ago, like 2 or 3 years ago, Copay wallet, one of the famous wallets, there was a hacking attempt. So someone hijacked one of the dependencies. He pushed the same version that the Copay uses, and they installed the malicious code. So good thing they called. But if you actually accidentally deploy it to production, you're screwed. Not just you, all your users will lose their money. And keep in mind that sometimes users might have like millions of dollars worth in their addresses, on their Entropy. So we don't want that to happen, right? So what are the ways to combat this? Well, the basics. You pin dependencies. You never use dependency with tilde or this arrow that says like let's go with random dependency that satisfies this. So you pin the dependency, and on your CI, the pipelines that build your application, you go with npm CI, which is kind of similar to npm install. But what it does, it downloads all the dependencies and checks all the hashes of dependencies that are registered in the package log.json. So if someone's doing something fishy, this will fail. So it will basically tell you, look, there's an exact version of the app. Someone pushed the exact same version, and the hash doesn't match. There's something fishy going on, so it will fail. And at least you'll be able to direct your attention to this and see what's going on in there. OK, this is not the best solution. So we use several solutions. Like one of them is using monitoring bots that will send you dependency bumps if one of the dependency changes, or if one of your dependency has a vulnerability or it's just hacked. It will send you a PR with a fix. The sneak bot, it is one of my favorites. But we've got other options like Renovate bot, Dependa bot from GitHub, or Socket Dev, which also monitors your dependencies. and it will tell you if something is fishy. Yeah, the bottom line is that supply chain vulnerabilities monitoring is a huge niche in security. So all the security firms will provide you some kind of solution with supply chain attacks protection, and this is one of them, bots. Yeah, if you're working in a big company, chances are you already have some kind of local packages or artifacts registry, and this is forced down your throat by security teams. So don't refuse it, just go with it, because this is for your own good. So there'll, like Verdaccio or Artifactory, there'll be some kind of mirror of your node modules on your own company, which your own security team verified, read through the code, and said, okay, this specific version is actually good for production, so let's use it. We've got other options, like you can fork the dependency under your own organization, and every time you pull upstream to make it up to date, you read the diff to make sure that there's no fishy stuff going on, okay? But this is like time consuming. There are dumb solutions, like if you just code the dependency from node modules to some blah, blah, blah modules and commit it to Git, it will just work like magic. So this will this will provide you some kind of control of what you're using in your software. Or I might be so bold, just don't use dependencies. Implement everything from scratch. Well, not everything, but if you need like 10 lines of code, don't use dependency. Just write these 10 lines of code. You'll be safer in the long run. So, but if you really, really, really need to add dependencies, please try to use dependencies that don't have other dependencies. This is called transitive dependencies. You'll be amazed. You can run npm ls and package name, and you'll see how many dependencies other dependencies have. This is like a huge tree. This is the reason why node modules weighs like gigabytes. So transitive dependencies is really bad. This is something you cannot control. If you can control the first level of dependencies, the second level and other levels of dependencies just out of your control. So this is important. Kudos, we've got the working cryptocurrency wallet. So we're left with some other tricks, like we have to be careful with crash and analytics service. Like accidentally, we might leak personally identifiable information of our users to the monitoring services. And users usually don't like that. The users that have millions of dollars under their control in your app, they don't like that. I don't know why. So the less information you have on your users, the safer they are. And don't leak secrets. Like recently, there was a really big hack. I think it was Phantom Wallet, but I don't remember if it was Phantom Wallet or the other one. It was one of the Solana wallets that accidentally had console log in their code, and they debug printed the secrets in their apps, like private keys. And it got leaked to the Sentry or whatever in plain, not even encrypt, and money were stolen. Yeah, you stupid, just stupid. Yeah, so don't do that. So be careful with Sentry or whatever analytics you're using. Other things, over-the-air updates is also a bad idea because it increases attack surface. So if you're safeguarding millions of dollars, you don't want to have a random developer on your team who can just force push some updates to all your users randomly. Like you need to control this. So over the air, it's actually a good developer experience, but it's bad security practice. So if you're building cryptocurrency wallet, most likely you don't want over-the-air updates. And if you're serious about your software, you will need a security audit from legit experts that costs real money. Actually, it's not cheap. It's like tens of thousands of dollars per audit. But this is worth your investment. Another curious thing is like Apple and Google treat cryptocurrency wallets as fintech software, so they have tighter restrictions for cryptocurrency wallets. For example, Blue Wallet had to re-register the company name because the Apple didn't like the company name we had in 2017. So they asked us for our company name to resemble the name of our flagship product, which is Blue Wallet. Yeah, and always think what would hacker do. This is called adversarial thinking, and always think what could go wrong, how can you leak your secrets, how can you screw up your users, and try to prevent it. And of course, use standards. Like, for example, one of the most famous standards are BIPs, Bitcoin Improvement Proposals, that usually include a range of standards for doing this and doing that and doing that. And if you're going to use the standards, this will mean that your users will have interoperability with other wallets. They'll be able to take their Entropy, their mnemonic seeds to other software and restore if you go out of business, if you just don't work, if your app crashes all the time. They'll be able to use other software to get access to their money. Yeah, and less chances that you will shoot yourself in the foot. Yeah, another cool trick that I invented is that, I remember I was talking about being on a bleeding edge. So sometimes things might work in emulator, sometimes they work in node.js in your tests, but then they magically fail when you build for production. Because of the bundler or because of the bundler usually. And usually this is because of cryptographic operations that used in packages that you use that are not designed for React Native. Things will just crash in production and you will wonder why. So the solution I came up with is just you have a small subset of your tests, usually revolving around the cryptography part, that runs in the runtime. You literally have a screen that when you go to the screen, it will perform the small subset of tests and tell if it's okay or it's not okay. And run those tests on both environments, on both Android and iOS, on CI, on end-to-end tests. And this is quite helpful. I find this quite helpful. And that's it. Follow me on Twitter, shoot me an email if you have questions. This is our wallet we're working on. It's called Blue Wallet. This is the almost final slide. And we've got some advanced stuff if you want to study it, like be mindful of your dependencies that you use, like because if you're building for F-Droid, they don't like non-free open source licenses. Reproducible builds are really hard with React Native, but kind of important for very privacy and security focused users. And with some efforts, you can ship as well for macOS and for Windows. And that's it from me. Hope you liked it.
I've got a quick question to start off with, which was about the over-the-air updates, actually. So you mentioned that it poses a security vulnerability. I think what you were more referring to is like a dev process vulnerability of people pushing updates, which didn't sound like a security vulnerability to me. Have you found any security vulnerabilities with it?
It increases the attack surface. Okay. It's different.
So you're saying that it's more of a people could push.
Yeah. Imagine you've got the rogue developer on your team that when everyone out of office, at 10 p.m. he decides to push the malicious code to all your users to steal all their money. This is just an attack vector.
Okay, cool. Any questions?
Where should I store my crypto? On the Coinbase or on your wallet?
He's not going to be biased about that at all.
Yeah, you self-custody. This is why we do what we do. We build the non-custodial cryptocurrency wallets so people can actually have control over their assets. They're in control of their own private keys, and they don't have the counterparty risk.
Where do you keep your keys? Where do you keep your keys?
Well, you keep it either in your software, like Blue Wallet or whatever software, non-custodial cryptocurrency wallet, and you have a backup on the paper.
I was just testing you. Do you know some companies are working on, they're using quantum computers, going towards that to break the key. So, one day this all will just blow up.
Yeah, but they say if quantum computers will be able to break our cryptography, everything will blow up. Like all interbanking communications, all the world is screwed because we cannot communicate, we cannot do money transfers, nothing works, nothing is true anymore. Like, so this will be the least of your concerns. But actually there are quantum resistant cryptography that if necessary will be deployed. And in Bitcoin, for example, there is a layer of hashing, and it's not even theoretically possible to break hashing, even with quantum computers, because it's like a one-way process. So yeah, we're somewhat safe, if that's the question.
So how do you tackle all the error updates and what do you do?
We don't do over there updates. We do like regular cycle. You push the build gets through testing phase, then to moderators, and then to production. So no over there updates.
What about like state management in the app? Do you clear the like in-memory stores whenever you close the app, or do you do anything special?
That's a good question, because in iOS we have pretty good separation between apps, and you can read the white paper by Apple. How do they secure the isolation between apps? There is like several layers of signing from the file system level. There is a private key of app, then the directory, then the file system, then the CPU. So it's like a tree-like encryption in Apple. On Android, I don't know. I wouldn't trust Android like with any money. I don't know. But yeah, but it's a good idea to not have your private keys in random access memory and to wipe them as soon as you're done with your operation. So you'll probably want to store your private keys on the secure enclave, like key store, and pull them out only at the time of signing, like to sign something, and then wipe the random access memory and not have it in random access.
You mentioned earlier about the entropy buffer on operating systems. When does that get cleared, or does it get cleared? When does that start filling up, essentially?
I don't know, but this is the good part about this is that there's a lot of eyes that are reading the source code of Linux or of macOS or Windows, I hope. I don't know. Maybe Bill Gates reads this code. I don't know. But at least in Linux, there are a lot of eyes who read the source code, professional cryptographers that make sure that the cryptographically secure pseudorandom number generator on Linux is actually secure. And there's a buffer that's secure. So I don't know how it's stored or where it comes from. Usually, if you read cryptography papers, it will mention this trick that I mentioned. It reads some kind of sensors and then stores it in a buffer. But modern CPUs have dedicated stuff to generate randomness. It's called true random something, TR something. I don't remember.
Are you using or consider using certificate pinning for network requests?
I think this is up to you. So if you're using only one service, you could pin the certificate. I personally don't, because we fetch data differently. We don't query public APIs in our app. But other apps, they do certificate. This actually, I should have included in slide. Silly me. Good catch. Yeah, do certificate spinning. Yeah, this helps.
What was your main motivation for building the wallet with React Native compared to other technologies?
Well, in 2017, I knew how to write JavaScript. That was the main motivation. Yeah, and all other Bitcoin wallets sucked, so this was a no-brainer.
Can we give a round